Welcome back to our podcast series we call Lime Time in Texas. My name is Dale Wren. I'm the Executive Director of the Lime Association of Texas. And today I'm going to be talking about the design stage of successful soil stabilization. And really this applies to all roadway construction. I'm going to start off by showing what I call a three-legged stool. I've done a previous presentation where I kind of introduced this topic about the three key phases of successful soil stabilization. They really boil down to design, materials, and construction. The focus of this presentation is going to be only on the design, so I'll go into a little bit more detail on some of the most important things we need to look at when we're talking about the designing, particularly as it relates to subgrade stabilization. So first of all, some of the design considerations are, do you even need to stabilize the subgrade? Some things that you need to look at here is just start off with the geotechnical investigation of the soil, of the in-place soil that's out there, and see what, that'll tell you kind of whether or not you need to stabilize it or not. You can utilize existing soil maps and things like that to kind of get you started to see if you're in an area that is more likely to need soil stabilization. You can perform field testing using things such as the falling weight deflectometer and the dynamic cone penetrometer. We call it FWD and DCP. Then you typically are going to need to perform a pavement design using the FPS, which is the TxDOT pavement design system, or the AASHTO design system. There's several of these out there, but one way or the other, you end up needing to go through a formalized pavement design. The final bullet here talks about just considering the performance history. So one thing it gives you a pretty good idea of whether or not you're going to need to do soil stabilizations is if you're in an area that typically does need that, and you can look back and see how those different maybe types of soil stabilization techniques have performed. So starting off with some things we've talked about in the past is that there's a lot of different soil types out there. They really boil down to the main three, which is clay, sand, and silt. So you need to have a pretty good idea of what you have out there before you kind of make a decision on whether or not you're going to stabilize and how you're going to stabilize it. These different soil types have different characteristics in terms of strength, cohesion, plasticity, their drainage characteristics, and things like that. So you need to really quantify that up front. There's some maps that are available. This is a very common one that we use in Texas that shows where we have expansive soils. So in the lime industry, we kind of have a pretty good idea of where the most expansive soils are in Texas. We show this in a lot of our podcasts because this is where most of the lime gets used for soil stabilizations, are these areas that are red and yellow in there where have frequent or fairly frequent occurrences of highly expansive clays. But again, you can find clay soils any place in the state, and just looking at those pictures there on the right hand side of the screen, you'll see some of the characteristics of when you have a clay soil. They dry out, they crack when the soil conditions are dry, and they can expand and have other problems if the soil conditions are wet. If the area that you're going to try to build a subgrade looks like this, where you're going to have the soil sticking to tires, gives you a pretty good idea of whether or not you're going to need lime or not. So in this case, I would say, looking at that picture, you would definitely need to use lime as a stabilizer. There's some soil maps that are available. These are just very good tools. I put the website there for the soil survey maps that you can go in and look at. Now, I stole these. I have to give credit to Tom Scullion, who's a researcher with Texas A&M's TTI, Texas Transportation Institute at A&M. But Tom, actually I stole several of his slides, so I'll just give him credit up front for any of these, or several of these that you're going to see here shortly. So, but this is the website you can go to, and some things that you can plug in there. You can look, for example, this is the project he was looking at down in the Laredo district, and just looking at the existing soil maps that are available through that service. And you'll see here that it classifies these by color based on the plasticity index, which the dark blue here is going to be the areas that have higher plasticity, more expansive. The red and yellow colors are going to be the ones that are more sandy type materials. And again, these are just good tools to use at the design phase to figure out what you're going to need to get started with on the design, and whether you're going to need to stabilize. Some of the tools that you can use out in the field, and this first one is a dynamic cone penetrometer. This is the kind of the cheap and easy version of it. I'll click on this video. You'll see that how this works. It's just measuring how much that cone penetrates into the subgrade. They're actually testing all the way down through the pavement there, but that'll give you a pretty good idea of whether the subgrade underneath it is offering good support or not. This next one is a little bit more expensive piece of equipment called the falling weight deflectometer. You can use this as on an existing pavement or on a new construction site. This will tell you how strong this existing subgrade is, and so you can back calculate those values, get a pretty good idea of what you're looking at out there on the project. So these are just very good background tools to have to look at to give you an idea of how to get started on your design. The next thing you need to do typically is to go out and do a geotechnical investigation, take some soil samples, bring them into the lab. Here's just a list of the typical tests that you would run. I'm not going to read through or discuss all of these. I will cover the last two on the list, as sulfates and organics are the ones that are two that are critical to measure. But the rest of that is just determining what we call the Atterberg limits of that soil. That kind of tells you whether you're in a clay soil, a sandy soil, or a silty soil. These are just some general guidelines, but generally speaking, if you have a plasticity index after you've tested that material and it's above a 15, generally speaking, you're going to need to stabilize that soil. If you're in a plasticity index above 35, you've got what we can consider to be a highly expansive soil. So you definitely are going to be looking at using lime as the stabilizer of choice when you have that type of situation. And the last two bullet items here talk about sulfates and organics. So these are two really pretty critical ones, and I'll talk about these a little bit more at the end of this presentation. But if you have sulfates that are greater than 7,000 parts per million, you have potential for sulfate heave and some other things. So lime may or may not be your best choice. You may have to use select fill on a situation like this. In some cases, particularly if it's 7,000 or less, you can typically mitigate that problem. But if it's above 7,000, there's a whole different guidelines that TxDOT has on how to deal with sulfates. The same with organics. If you have 2% or less, we can typically deal with that fairly easy if we're using lime as a stabilizer of choice. But if those organics get much above 2%, then you may have to look at something else as a stabilizer, or you may need to look at just using select fill. So that's some of the decisions that you'll need to make at the design phase. So the next question you have is, what type of stabilizer do you use? Now that you have all this information about what the soil is, then you can go in and use established guidelines. Like, for example, TxDOT has established guidelines that they've developed for the last 50 to 75 years based on their experience, based on all kinds of research that gives guidelines on what you should use based on the soil type when it comes to soil stabilization. Nationally, you can also find some other guidelines that may differ from TxDOT's a little bit, but TxDOT, since we're in Texas, that's a very good place to start. This is just a picture of the cover of that document that was last revised in 2019. They're in the process of revising that again now. Very good guidelines, and I'll just kind of jump in to hit some of the highlights of that. But if you plug in those Atterberg limits that you tested the soil, it's going to tell you really what type, if you need a stabilizer, and what type of stabilizer. And I'm just going to give the one example on the far right hand side. If you're above a 35 PI, you're definitely looking at lime or some type of lime cement, lime fly ash combination. Generally speaking, when you get into that high PI, lime is about the only choice that you would typically have for stabilizing those types of soils. The next question is, let's say that you've gone through and you've done all this testing and you know that now I'm going to need to use lime. Well, how much of the stabilizer do you need? Then you go back and you follow the test procedure, and it's saying the bullet item here, it says follow Tex-121-E part 3, which is the Eades-Grim test, also known as the Eades-Grim test procedure, or doing a lime series. That'll tell you what percentage of lime that you need to use. You can go to the Lime Association at limetexas.org website, plug in that percentage. along with the unit weight of that soil, and it will tell you exactly how many pounds per square yard that you need to spread out on that subgrade to stabilize it to a certain depth. So those are some tools that are available to you to use at the design phase. This is just a picture of 121E Part 3 that shows how the process works, and it's basically just adding different amounts of lime until you get the pH up to 12.4, and it repeats. And this is an example of one that would say that we have a select 6% as the amount that we need. Moving on to some other design considerations is how thick does the subgrade need to be? Well, this is a function of, one, the pavement design, so you're looking at all of the different layers that you're going to put into a pavement. It's also a function of the constructability and some of the practical limits of how thick you can mix the additive. So for example, a lot of times people, if they know they're going to use lime, they're going to try to use 12 inches or less because we know that we can mix that in one lift. If you have to do more than that, then typically it's going to require 2 lifts, requires a little bit more time. So sometimes you can vary some of the other, like for example, you may be able to increase the base layer rather than the subgrade, the lime stabilized subgrade, but it all really boils down to a good pavement design and working that in with it to figure out exactly what that depth needs to be. But that is something that needs to be determined at the design phase. The other one, the last bullet item I put down here, is it could also be a function of the potential vertical rise. So for those of you that's not familiar with this term, or PVR, it's how much that pavement can expand and rise up under the right, or I would say right, or the wrong moisture conditions. So generally, most agencies have limits on how much potential vertical rise you can have, and if you have too much, you may have to increase that lime stabilized depth underneath there to reduce that potential vertical rise. So just another thing that you need to consider as part of that pavement design. So this is just a typical pavement design. We show this in a lot of presentations where you have an example of hot mix asphalt surface, a base material, and a raw subgrade that's a clay subgrade that's got really poor support, where we're going to go in, modify it, use a lime stabilization, and so all of those factors boil down into plugging that into your pavement design process. Again, in Texas, we use the FPS is the most common one we use, and it will tell you what each one of those layer thicknesses need to be. Some other design considerations are, and I guess I answered this question already, but do you need to test for sulfates and organics? In Texas, we say yes every time your investigation needs to do that. Now, some states or some other parts of the country may not have sulfates or organics. There are some places in Texas that don't have sulfates or organics, but generally speaking, it's always a good idea, unless you're 100% sure that you don't have these, to test those. So, because if you have sulfates or organics, you need to accommodate them. Sometimes just putting it in your specification that if you know you have sulfates, let's say you're in the 5,000 to 7,000 range, you typically are going to require a longer mellowing period. So that's in a lot of the specifications, or a plan note that you need to have that taken care of all at the design phase. And really, I guess I probably should have said this up front, but when I talk about the design phase, really the design phase is what is the geometric design and what you're going to do, but also the wording that you put in the specifications of how it's going to be built. So I kind of consider design and specification to be all part of the same package there. So just kind of summarizing this, the 3 keys of successful soil stabilization are design, materials, and construction. This 3-legged stool won't stand up unless you do a proper design. So today's presentation is really only focus on getting that first part of that right. That doesn't mean you're going to have a successful project. You're still going to have to get the right materials and put them and construct them properly, but it gives you the best chance of having success if you know that the design is taken care of properly. I'll just repeat what we've said, a few other considerations here. The term that if you expect it, you have to inspect it. Prior to inspecting it, you have to put it in your specifications. Start with the real clear expectations of what you expect on that project. So again, things like in the design that you expect to have a 95% in-place density, you have to have a note, or you have to have specifications that call out that 95% density. Then the second note, the second bullet here applies where what gets measured gets done. Not only do you have to specify that it gets 95% in-place density, you have to go out there, somebody has to go out there and measure it, along with inspecting all the other elements that are involved with that. But that's just kind of one example of what has to be done on the design phase. This gives you the best chance, if again, on the design phase to have success on a project, which again, it always boils down to good design, good materials, and good construction. I thank you for your time today and hope you've learned something new about how to build a successful subgrades and really any kind of successful pavement construction. Thank you. Thank you for watching this episode of our podcast. If you want to learn more about the use of lime, reach out to us on our website at limetexas.org. You can also email me at dalerand@limetexas.org. And please follow us on LinkedIn and subscribe to our YouTube channel. Thank you for watching.